Hello everybody. Today I wanted to just show you a couple different approaches that students took to solving the first of the identities on our quiz. That identity was that the secant squared of x minus 1 divided by secant of x eventually simplified to, I want to say it was sine of x or something like that. We'll look and see how that happens. But some of the different approaches, a very common one was to convert things into sines and cosines, and I wanted to show you a trick. If you choose to do that, you often get these little tiny fractions inside of fractions. For instance, this little 1 over cosine in the numerator and this 1 over cosine in the denominator, which is kind of awkward to work with. And so a nice trick that you can do is to multiply the top and bottom by the denominator, or the biggest denominator that you see at least. In this case, I see cosine squared of x on top. Let me multiply top and bottom by cosine squared of x and just show you what that simplifies to, and I think this will be a trick that you can use in the future. On the top, that cosine squared of x has to be distributed to both terms, and it cancels out the cosine squared of x in that first term, which gives me a 1. And then cosine squared of x times 1 is, of course, cosine squared of x. And so on top, I have 1 minus cosine squared of x, which I'll immediately replace with sine squared of x, because that's a Pythagorean identity. On the bottom, the cosine squared of x times the 1 over cosine of x gives us just a plain old cosine of x. And now I think, since I forgot what the other side has to look at, I'm pretty sure the other side is probably splitting this up into a sine over cosine, which is tangent, and then another sine. So I have a feeling that this was supposed to equal sine times tangent of x. So anyway, takeaway point is, if you have these little mini fractions inside because you converted things into sines and cosines, taking a moment and multiplying the top and bottom by the denominator, or the biggest denominator that you see, that'll clear all those fractions and give you something easier to work with. Another approach that I saw, which is a very common theme, is to notice that I've got something squared times 1, which is also 1 squared. So basically this is a difference of squares, and so factoring this using the 2 things added and 2 things subtracted technique is kind of cool. Secant of x plus 1 and secant of x minus 1. Those 2 things multiply together to give you this secant squared of x minus 1. And unfortunately, in this particular instance, this is kind of a dead end. It doesn't actually help us. There isn't an easy way to proceed from here. But I didn't know that ahead of time. I tried it, and a lot of times in identities, that's what you need to do. You just got to try something and see what happens. Like I said, this one, kind of a dead end. Another common thing to do, and this one actually is very helpful in this case, is if you're taking 2 things and dividing it by 1 thing, you can break that up. It's kind of like using the distributive property. I need to divide both of these terms by secant of x. So I've got secant squared of x over secant of x, and 1 over secant of x. And the first one is just, well, secant of x. And then the second part, 1 over secant of x, maybe you can do some further things with, or you can write that as cosine of x. And again, you can eventually move things around and get all sorts of interesting things from this. But that, again, breaking this up into 2 different parts is kind of a useful tool. So probably the fastest approach, and what I saw probably 10 out of 30 people do, is notice right away that secant squared of x minus 1 can be rewritten by using a Pythagorean identity. That's the same thing as tangent squared of x. And so this, if you split tangent into sine squared over cosine squared, and in the bottom secant is 1 over cosine squared, When I've got a fraction divided by another fraction, then I find it helpful to rewrite that as multiplying the first fraction, which is sine squared of x, over cosine squared of x, by the reciprocal of the bottom. And so the reciprocal of the bottom is cosine squared of x over 1. Oh, where did that squared come from? That shouldn't be squared, should it? Or was it squared? I don't remember. Anyway, the point I wanted you to take away from this is this multiplying by reciprocals bit. Now I see that I've got cosine squared on top and cosine squared on bottom, and so those two factors will cancel themselves off, and I'm left with sine squared. So I realize that I've got like 3 different results in all of these, and I think it's because I didn't exactly copy it directly from the quiz. I hope that that doesn't annoy you, but I hope you see instead the different tools, the different things to try, and that you'll take away from that the concept of multiplying top and bottom by a denominator to clear little mini fractions, splitting up a numerator into 2 different terms, and or multiplying by reciprocals as different ways of dealing with fractions inside of fractions. So take a look back at number 1, and if you've already verified it, try verifying it a different way. That's good practice. And if you haven't verified it yet, take a closer look and make sure that you've got the right identity typed in, as I don't think I've got the right thing here, but and see if one of these different approaches will help you in the future. Hello again, and here's a approach for verifying the second of the identities on our quiz. And so in this identity, I've got 2 pretty ugly looking fractions that add together to create 2 secant of x. And there really is not any other approach besides at some point having to add fractions. And so in order to add fractions, you need a common denominator. So in this particular problem, this fraction has a denominator of cosine of x, and this fraction has a denominator of 1 plus sine of x, and so the common denominator is probably one that has both of those. And in order to get that, I'll have to take the first fraction and multiply it by the denominator of the second, and take the second fraction and multiply it by the denominator of the first. So let's see what that gives us. This first one needs a factor of 1 plus sine of x on bottom and top. And the other fraction needs a denominator of cosine of x on top and bottom. So that means I've got to multiply 1 plus sine of x by 1 plus sine of x. I'll have to use the foil pattern to do that. On the other side, I just have cosine of x times cosine of x. That's not going to be too ugly. On the bottom, I've got 1 plus sine of x and cosine of x. And a common mistake I see a lot of students do is the bottom, multiplying that out and getting cosine of x plus cosine sine of x. Factored form is your friend in this case. If you can have something in factored form, it's kind of nice because you can maybe have a common factor on top that you can cancel out. And so I'm going to leave the bottom in factored form. The top is not in factored form because there's 2 things being subtracted. I'm going to have to expand this entirely and then combine like terms and hope that what is left on top might be able to be written in factored form. And usually these identities are written in such a way that that can happen. So let me simply copy and paste this a little bit. And let's leave the bottom the same and multiply the top out. This side's easy. That's cosine squared of x. This side is a little bit more tricky. If you use the first outers, inners, lasts acronym, then I've got 1 squared. I've got 1 plus sine. That's going to be 1 times sine is sine of x. And then I've got another sine of x. and then sine times sine is sine squared. So let's see, get rid of that. If I take a moment and combine these two like terms, then I've got 2 sine of x and I realized I made a mistake. This was being added at the beginning, and so this should be a plus sign, not a minus, and therefore this should be a plus sign, not a minus, and this should be a plus sign and not a minus. And here I'm kind of excited. I see a chance where I can use the Pythagorean identity. Sine squared plus cosine squared, that is the same thing as 1. So let me rewrite that again, but instead of having this, I'll make a substitution. I'll call that 1. And I'm thrilled again because I see 1 and 1, and I can add those together. So that gives me on top 1 plus 1 is 2. And lo and behold, I can factor the top now because they both have a common factor of 2. And so I can pull that out. 2 times 1 plus sine of x is what the top factors to, and the bottom is still 1 plus sine of x and cosine of x. And lo and behold, there's a common factor. The 1 plus sine of x on the top cancels out with the 1 plus sine of x that's on the bottom, and so I'm left with the very simple fraction 2 over cosine of x. And when you divide by cosine of x, that's the same thing as multiplying by its reciprocal. The reciprocal of cosine of x is secant of x, and so 2 secant of x, and that's exactly what I needed to find. And so, again, a common theme, create a common denominator. Another common theme is factored form is your friend. If you can get the top and bottom to be written in factored form, cool. Then you can cancel out factors, and a lot of times that simplifies expressions. So. Hello again, and in this video I want to show you how to solve the third of the identities on the first quiz, and this is the one that I think was probably the most difficult. I struggled with it because I got confused with signs, and I took an approach that wasn't the easiest approach, and I didn't know that at first. But anyway, let me show you just a couple of different things that people have done. Our goal is to turn cotangent squared of x divided by 1 plus cosecant of x into 1 minus sine of x over sine of x. And so one approach that, again, is fairly common is to convert things into sines and cosines. And so if we do that, let's look at that, what that looks like. Cotangent squared is the same thing as cosine squared over sine squared. Oops. And cosecant is 1 over sine of x. And earlier in our first identity video, I showed that a helpful trick when you've got these kind of fractions inside of fractions like that is to multiply by the biggest denominator that you see, because that might clear those fractions and give you something a little bit simpler and easier to work with. And so in this case, the biggest denominator I see is the sine squared, and so let me multiply top and bottom by sine squared over sine squared. And so on top, that gives just plain old cosine squared of x. And on the bottom, I've got sine squared of x minus, and then the 1 over sine and the sine squared, one of those signs cancels out, but the other one doesn't. And so I have sine squared of x plus sine of x. And in our second video, I mentioned the fact that factored form is our friend. It would be nice if we could write the top and bottom in factored form. Technically, the top is in factored form already. It's just cosine squared of x. Nothing too fancy there. The bottom can be factored if I pull out the sine. And so I see sine of x times sine of x plus 1. And it seems like we might kind of be stuck because I've got no common factors. But a common trick to do, as we've seen before, is to replace cosine squared of x with 1 minus sine squared of x. We usually do it the opposite way, but it has the advantage here of now we've got an expression that's just sines involved. There's no mixture of cosines, and that's what our goal is too, is just sines, and so that might be a worthwhile thing to do. So let's replace the top with 1 minus sine squared of x, and then the bottom we'll leave in factored form. Again, factored form's our friend. And a common thing, if you notice, this is 1 squared and sine squared, so the top can be written in factored form pretty easily by using the difference of squares pattern. And so we've got 1 plus sine of x and 1 minus sine of x. And the bottom is still sine of x times sine of x plus 1. And it doesn't look like these are the exact same factor, but 1 plus sine of x and sine of x plus 1 are the same. If I just wrote these two terms added in the other way, you could see that. And so this factor here and this factor here can cancel out, and so that gives us 1 minus sine of x over sine of x, and that's exactly what we needed. So again, converting things into sines and cosines can work, but this expression was kind of ugly. If you didn't realize that you could clean it up by multiplying by the denominator, well, now you do. Try that again in the future. What made this extra difficult was the factoring out, I think, and trying to get these into factored form was not super obvious until you made a substitution and got there. So anyway, that was one approach. Another approach, and this was the approach that I tried when I first tried to solve it, was I remembered my math teacher told me, hey, if you have a binomial, two things being multiplied together, a helpful thing to do is to multiply by the conjugate of that. And so multiplying by 1 minus cosecant of x on top and bottom. The reason this is a helpful move is that the multiplication in the bottom is a difference of squares, and you produce something that is 1 minus cosecant squared of x, and that is probably something we can replace with a Pythagorean identity. In fact, it might be cotangent squared of x. That'd be really nice, because then the cotangent squared would cancel out. So unfortunately, it's not cotangent squared. It's a little uglier than that, and that's what threw me for a loop, why it got hard for me. 1 minus cosecant squared of x, we can find an expression for that if we take the identity, 1 plus cotangent squared of x equals cosecant, and if I subtract cosecant squared from both sides, oops, how do I make that? There we go. And while I'm at the same time, I'm going to subtract cotangent squared from both sides. And on this side, do the same thing. And that produces 1. The cotangent squareds cancel out, but I still have a minus cosecant squared of x. And on this side, the cosecant squareds cancel out, but I've got a minus cotangent squared of x. And I didn't catch that minus part, and I made a substitution and went down several several more steps before I realized what I had done. And anyway, that proved to be more difficult than it should have been. So anyway, to continue this, the bottom could be replaced with with a negative cotangent squared of x, and the top has a cotangent squared of x, and the factor 1 minus cosecant of x. Again, I'm going to purposefully not multiply these together because multiplying those together, well, because I want factored form. I want to be able to cancel out those cotangents. And so if I do that, now I have on top 1 minus cosecant of x, and on the bottom a negative factor, a -1 factor. And so if you divide both of those things by -1, you've got a -1 and a positive cosecant of x. And it doesn't maybe look like we're close to what we want until we convert these into sines and cosines. We've got -1 plus 1 over sine. And if I do a trick of rewriting 1 as sine over sine, with a little bit of work, eventually you can rewrite that and turn that into the left-hand side. This is probably not the easiest approach, to be honest. It worked, and a lot of times multiplying by conjugates does lead somewhere, but just because of the way things were given, it proved to be more difficult than it should have been. No, I don't want to keep you. Go away. So the other approach that I saw a few students do, which I wish I had done, I didn't see it, but now I do, was to replace cotangent squared pretty quickly with a Pythagorean identity. And so let me get a brand new one out here. If we look at our original Pythagorean identity, if I subtract 1 from both sides, then cotangent squared of x is equal to cosecant squared of x minus 1. And so if I take that expression and replace the top with it, then the top factors pretty simply. It's the difference of squares again, and so you can write that as cosecant of x plus 1 and cosecant of x minus 1, and the bottom is 1 plus cosecant of x, and those terms, this first term here and this first term there, are identical, and so they can cancel themselves out, and you get cosecant of x minus 1. And eventually, by replacing cosecant with 1 over sine and 1 with sine over sine, in fact, let's do that. I haven't had a chance to do that yet. 1 over sine of x minus sine over sine gives us, if we combine the tops now, because they have a common denominator, 1 minus sine of x on top of sine of x. There's our left-hand side. So pretty straightforward. Just a couple quick little steps if you make this substitution at the beginning. So anyway, lots of different approaches to that one. I'll admit that one was a challenge, but I hope you were able to try a few things, and if you haven't gotten that last one, try one of these approaches, see if you can write it out on your own, and feel free to check back with the video if you get lost for a step along the way. So